Namaskar. Good afternoon, everyone. Today we will be doing the second session of this particular course. The title of the course is AI and ML for geodata analysis. So in today's session, what we will be talking about is for machine learning algorithms. What is machine learning and what are machine learning algorithms? So prior to starting with the technical content of this session, I would request I would again announce that since in this particular course we are having a large number of participants, I request all the participants to watch the sessions through YouTube, IIRS YouTube channel. The participants who have registered as the individual participants, then they can, after the end of the session, they can log in into ISRO LMS, and they can appear in the quiz, and based on the daily quiz they will get the certificate. The participants who have registered via the nodal coordinator, they are also requested, if they are not able to log in into e-class, then they are requested to watch these sessions through YouTube. However, for their attendance, they can ask their coordinators to mark their attendance in ISRO, in IIRS LMS. Okay, so I request cooperation from all the participants so that you all can have a very fruitful learning experience in these 5 days. Okay, so coming back to the topic, today we will be talking about machine learning algorithms, and I am Dr. Poonam Tiwari. So we will be starting our session with the words of Professor Gareth James. He was a professor of data science operation in a big college, and he said that for the 21st century, data is the sword, and whoever is able to handle that data properly, he will be called as a samurai. So we are in that era where the data is very, very important. And to handle a large amount of data, we require advanced algorithms, and machine learning, deep learning is one of the set of algorithms which we are applying in all spheres of life, since we are having a large amount of data, and these type of algorithms will only work when you have large amount of data. So now let us talk about what is machine learning, what are what are so yesterday madam has already discussed about what is artificial intelligence, and she must also have told you that machine learning is a subset of artificial intelligence. So artificial intelligence is anything in any function where the machine behaves like a human. Machine learning is a subset of artificial intelligence in which the computer is trained to automate a particular task. In machine learning, what we do is the algorithms, they use the data and it is fed into the algorithm. The algorithm tries to understand the data set, and it tries to understand the relationship between the input and the output data set that we have provided, and it learns and it extracts the features, it learns on its own. And when machine has finished learning, it can predict the class of new data point, or it can do the classification, it can do any of these operations that we are talking about. The deep learning is further a subset of machine learning, which uses deep neural network. So tomorrow in the session, we will be talking about what is neural network and how these neural networks are used for doing the doing the processing. So in deep learning, the machine uses different layers. A large number of neural networks or layers are used, and progressively these layers go on learning from the data set. How deep is the model tells me how many number of layers are there. Uh, if the model is deep, we assume that it will be having more, means it will be a better model, but it is not always true. So these are what I have listed out here are the differences between the machine learning and deep learning algorithms. So talking about the factors based on which we can differentiate between machine learning and deep learning. So the first one being the problem solving approach, how it is attempting the problem. So in case of machine learning, what machine learning does is that the features which will be used for doing the task, for doing classification in our case, because our course is titled machine learning deep learning for geodata analysis, and in geodata analysis we are generally doing the classification and clustering of the data set. So the features that we are using for classification, that is extracted, that is manually extracted in machine learning, whereas in deep learning it has minimum human intervention, and it does the means what features it will be using, we don't know. Coming to the training methods between machine and deep learning. In machine learning, we have a large number of training methods. We have supervised, unsupervised, reinforcement, semi-supervised, self-learning. So many types of learning is there. Whereas in case of deep learning, we have autoencoders, GAN, generative adversarial networks. We have convolutional neural networks. We have RNN, CNN. So these structures are there, these architectures are there. They learn on their own. Then how means what is the complexity of algorithm? In case of machine learning, we have diverse algorithms. We will be seeing today that we will be starting with very basic algorithms, and there are advanced algorithms such as random forest classifier, such as SVM, which is support vector machines. Whereas in case of so the complexity of algorithm varies. Whereas in case of deep learning, we the architecture is basically made up of interconnected neurons, and the architecture is somewhat complex. Now, how it relies, means how it interprets the data. So, if in machine learning, we always, the data should be well structured. Whereas in case of deep learning, we since it is based on artificial neural networks, it takes all the data set and it finds out the features itself. So any type of means large amount of data is required. And how the means what would be the infrastructure and data requirement in case of both the machine learning and deep learning. So machine learning data and models can be deployed and executed on single instance on or distributed across server cluster. Whereas deep learning models, because they are quite complex and they rely on large amount of data set, so it requires a large amount of storage and also computational power also. So these were the key differences between machine and deep learning. Today, in today's session, we will be focusing mainly on machine learning. So what is machine learning? Machine learning is a method of data analysis that automates analytical model. So till now, in the traditional programming, what we were trying to do, we were giving the program to the computer. The program was written by the analyst, by the programmer, and that program was given to the computer. Along with that program, when you provide the data, it gives you an output. So suppose you want to add some, means create sum of two numbers, 5 plus 3 is equal to 8. So you have to give the program that value x plus value y. So you have to apply that operator yourself. Okay, and it gives you the output. Now whenever you feed any other value for x and y, suppose now you feed value x as 4 and value y as 5, then the output that you will be getting will be 9. Now what happens in case of machine learning? In machine learning, we are not giving the program to the computer. We are giving the input and the output. Here I have given you a very simple example. So in machine learning, we are giving the input and the output. That means this is the question, this should be the answer. This is the question, this should be the answer. For every data we are giving what should be the output. Like this, and this type of data set is called as a training data. So when we are training the computer, we are providing all this information to the computer. Now we don't, the computer itself tries to find out what is the connection between the input and the output, or what is the relationship between the input and the output. And based on that, it itself develops the program, or it itself develops the logic. So in case of machine learning, instead of writing the program by hand, we collect lots of examples that specify the correct output for a given input. Now, the machine learning algorithm takes these examples and produces a program that does the job. And machine learning is programming computers to optimize a performance criteria using example data or past experiences. Now, there can be different type of machine learning algorithms. We can have supervised algorithm, we can have unsupervised algorithm, we can have semi-supervised, reinforcement learning. So a few of them we will try to discuss here. Now, what is supervised machine learning? Supervised means you are supervising the system. That means you are making it learn using the labeled data. That means you are telling the input and the output. Okay, so that kind of algorithms are called as supervised algorithms. Unsupervised algorithms, for unsupervised algorithm, you are not giving any training data to the system. Instead, you are asking the system to discover the patterns in the unlabeled data. Okay, so it itself tries to cluster the similar data points. Okay. Reinforcement learning is the one in which the computer or the algorithm uh, predicts something, means it does some job. If the job is correct, the reward is given or feedback is given to the system that the result is good. So it will improve its result. If the feedback is negative, that means if you are saying that the it is not good, then it will improve itself in that particular manner. Okay. So these are basically types of machine learning: supervised, unsupervised, reinforcement. In case of geodata analysis, we are generally using supervised and unsupervised algorithms. In supervised, we can have classification algorithms, we can have regression algorithms. In unsupervised, we can have clustering algorithms and association analysis. Okay, so lot many types of algorithms are there. One by one we will be talking about them. Now basically, what problems do we have in case using machine learning? What problems do we have? What do you want to do? Because nowadays you must have seen that ML is being used, MLDL is being used in all sorts of problems. But in our case, we are only talking about geodata analysis. In case of geodata analysis, we are basically dealing with three major problems. So here I have listed all the problems that can be done using machine learning. It can be the time series problem, also feature extraction, anomaly detection. So basically, in our case, we are talking mainly about classification, clustering, and regression. Now, what is classification? Classification is a problem where the answer to be learned is one of the finitely many possible values. That means you have given a complete image and you say that find out the land use pattern. So in the image there are so many number of pixels. Okay, so for every pixel it has to classify that this pixel is a vegetation pixel, or this pixel is a water pixel, or this pixel is a urban pixel. So such type of problems are called as classification problem, in which finite number of values can be there. And this is a supervised learning problem. Then we can have some problems in which the output need not be finite number of values. The output can be a continuous value. That means it can be, you can have 2.0, 2.01, 2.02, 2.02. So all these values can be can we get as output values. So such type of problems are called as regression problems. So numerical weather modeling, so all such type of numerical modelings are come under regression analysis. And this again is a supervised learning problem, whereas clustering is an unsupervised learning problem, where the structure to be learned is a set of clusters. So instead of classifying that this pixel belongs to water or agriculture or urban, what this system has to do is it will make the clusters of similar pixel. Similarity can be of based on any parameter, so that those parameters can be talked about later on. But based on some similarity criteria, the system, the algorithm, it creates group of similar pixels, and those group of similar pixels are called as clusters. So these three are the basic machine learning problems in the case of geodata analysis. So coming to supervised learning. In supervised learning, now what is supervised learning? To explain supervised learning, I have given an example here. So here you have some data in which there are tomatoes, carrot, and bell peppers. Everything is are there, and we give some labels. That means the picture of carrot, and we name this as carrot. Picture of tomato, we name this as tomato. Picture of bell pepper, we name it as bell pepper. And we give this input, the labels as input in my model. The model gets trained, and once the model is trained, we can test our model with the testing data also, and see whether my model is correctly doing the prediction or not. So once I'm satisfied with my model, I can give the raw data, and now on this data, it will do the prediction and say how many carrots, bell pepper, and tomato are. Okay, so here what we are doing is we are training our model. We are giving the training to our model. There, that is why such type of algorithms are called as supervised learning. Supervised learning algorithms are trained using labeled examples such as input, where the desired output is known. So now we can have training, validation, and finally prediction. In the training, we give the training data and we make the algorithm learn. We create the model. In the validation, we take the testing data on this trained model. We up we give this trained model the test data and see how accurately it is doing the prediction. So once my model is validated that okay, this is good enough model, then I can use the same model, and on that same model we can use new data set, and it will do the prediction. So this is overall the flow for supervised learning. So in case of geodata analysis, how it is doing, suppose this is my image, okay, and I want to do a land use land cover classification. We have, looking at the image, we have understood that, okay, there are majorly these 6 classes: agriculture, dry river, reservoir, forest, urban area, and open forest. So what we will do is we will try to identify pixels which are true representative of agriculture. Suppose these yellow area, this yellow AOI which I have marked, this is, we are sure that all the pixels below this yellow AOI, area of interest, represent agriculture. So I can select these pixels and I can mark them as agriculture. So now what the computer will do is, what my algorithm will do is, it will create some, it will do some statistical calculations. It will find out means, standard deviation of all the pixels, group of pixels like this. And this will be called as a training set or training data for agriculture. Like this, we can give training data for dry riverbed, for water, for forest, urban, and so on. So once this all is given based on this data set, now every pixel, starting from the first pixel of the image, every pixel will be labeled and it will be classified into any of these six classes. Now, these are the, this is the how this supervised classification is done in case of geodata. Now, what is the disadvantage? Disadvantage is that it is limited to learning from labeled data set, which are often expensive. So it is difficult to get the training data sometimes. Okay, and so it might be, if your training data is wrong, your classification results will be wrong. So if the data is less, the training data is less, or the training is not done properly, then the performance may be poor. These are some of the supervised learning algorithms that you must have read about or heard about them in different literature. So the learning algorithms can be classified into five different broad uh, classes: numerical classifiers, parametric functions, non-parametric functions, symbolic, and ensemble learning. We will not go into the details of these, but we will definitely look at a few of these algorithms. So the most simple, before going into the algorithms, we should also um, understand that how the training is done. Whatever data we have collected, it we will split it into three parts: the training data, validation data, and testing data. So training data is used for training the model. Validation data is used to determine what model hyperparameters, what adjustment has to be done. And testing data is used to get final performance of my of the model. So generally, whatever means, suppose we have collected 100 pixels, then 60 pixels we will keep for training, 20 pixels we will keep for validation, and 20 pixels we will keep for testing. So this is in general that we are using. Sometimes this is 60 20 20. Sometimes we use 70 30, also 70 for training and 30 for validation and testing, 15 15 for validation and testing. So these are some of the things which are mentioned in the literature. So we can select any of these. Now, the first algorithm that we will be talking about of machine learning is parallel classification algorithm. It's a very simple algorithm. As I have told you that once you provide the training samples, the system generates the mean and standard deviation. So suppose we have a two band data. I assume that you must be aware what are the different bands. Okay, so suppose we have two band data. So what we can do is, in band 1 and band 2, we can do a plot. Just to explain it to you, we have taken only two band data. You plot the mean of all the classes: mean in band 1, mean in band 2, mean in band 1, mean in band 2 for class 3, mean in band 1 and mean in band 2 for class 2 also. So we have plotted the means, and we can plot the standard deviation also. So mean plus 1 standard deviation would be the maximum value, maximum limit, you can see, and mean minus 1 standard deviation would be the minimum limit. So maximum and minimum limit we have in both the bands we have plotted. So when we plot these, we will find that we have got a box sort of thing. Okay, so boxes for all the classes are created based on mean and standard deviation. Now parallel algorithm is very simple. any unknown pixel which falls in any of these boxes will be termed at that as or classified as that particular class. That means suppose here we have uh, 5 classes, 1, 2, 3, 4, and 5. So pixel A, you can see here, pixel A is falling in class number in the box for class number 4. That means forest. So pixel A will be classified as forest, whereas pixel B is not falling in any of the classes. So pixel B will be left as unclassified pixel if we are using parallelized classification algorithm. Okay. So what are the advantages? It is very fast, very simple, and it gives a broad classification, thus narrows down the number of possible classes to which any pixel may be assigned before further time-consuming calculations are made. Okay. So if you're when you are plotting your clusters, your training samples, if you find that all the training samples are like this, that means in any one of the band combination, they are separated. And here you can see yellow is separate, green is separate, cyan is separate, red and blue, all are separate. These are the training samples. So if such is the case, then you can go for parallelized algorithm. The next algorithm is minimum distance to means classification. This is also very simple. So here what we have to do is we have to only calculate the mean of all the training samples. Here we have, these are the training samples you can see, and we have calculated the mean of the training sample. Now you take any unknown pixel, suppose in the same example, I have taken unknown pixel as A. Calculate the spectral distance of A with all the cluster means. With all the cluster means. This, and this training sample means. So whichever distance is minimum, the pixel will be assigned to that particular class. Okay. So here again, the pixel A will be assigned to class forest, whereas pixel B, instead of being left unclassified, it will be now assigned to class C, class 3, that is wetland. Okay. So this is minimum distance to means. Whichever pixel is having uh, the distance is minimum between pixel and mean. Whichever distance is minimum, the pixel will be put into that particular class. Okay. The advantage is that since every pixel is spectrally closer to one of the sample mean, so there won't be any unclassified pixel. And it is also very simple, very fast. The disadvantage is that the pixels which should have been left unclassified, they also become classified because it is not taking class variability. The standard deviation is not being considered during classification. Okay. So this is a case where minimum distance should be taken. The third one is Mahalanobis decision rule. Mahalanobis decision is similar to minimum distance because as you can see here, there we have not used the standard deviation or variance. Here we are using the covariance matrix also in the equation. So so that problem has been sorted out. So the advantage is that it takes variability of the classes into account, unlike minimum distance or parallelized. May be more useful that minimum distance in cases where statistical criteria must be taken into account. But since it is taking the covariance matrix directly, so it tends to overclassify the signatures with relatively larger value in covariance matrix. The equation is slightly bigger, so it is slower to compute than parallelized or minimum distance algorithm. Mahalanobis distance is a parametric algorithm. So here in such type of cases, you can, where the sample value clouds overlap, you can see it is having a complex shape. So in such cases, the Mahalanobis decision rule can be. The next one is maximum likelihood or Bayes decision rule. The maximum likelihood classification is based on the probability uh, uh, based on the probability that a pixel belongs to a particular class. The basic equation used is assumes that all these probabilities are equal for the classes if the input bands have normal distribution. So suppose we have some prior knowledge that the probabilities are not equal for all the classes, then we can specify weights for different classes. And when we are adding the weights, then this maximum likelihood decision rule is known as Bayes decision rule also. Okay. So Gaussian or maximum likelihood classifier assume that the feature vector of each class are statistically distributed according to multivariate normal probability density function. Okay. So you can see here, so in such type of cases where the training clouds are overlapping and all these are prolonged in shape, prolonged in shape tells us that they are having a large amount of correlation. So this indicates that we need to classify the image using maximum likelihood algorithm. So the classification results look something like this. The advantages is that out of these many classification pixel based, it is one of the most accurate classifier because it takes most variables into consideration. The disadvantage is that it is an extensive equation and takes a long time to compute. And it again tends to over classify signatures with relatively larger value in covariance matrix. Now, out of these algorithms that we have discussed, how should we select which algorithm should we take? So, first of all, we should go on answering these questions. How many classes are there? If we are only want to classify our image in two classes, then we should go for binary encoding. If there are more number of classes, so we should see, do sample values overlap? So if here you can see blue and brown, they are not overlapping. So in such cases, parallel algorithm would be the best. If the values are overlapping, then what is the shape of the point cloud? If it is complex shape, then we should go for Mahalanobis decision rule. If the shape is simple, then we have to see whether there is a correlation between sample brightness. Correlation, I told you, the elongated nature shows correlation. So if the correlation is there, then maximum likelihood. So in this case, red and blue, we can go for maximum likelihood. And if there is no correlation, we can go for minimum distance to means algorithm. Now coming to some advanced algorithms uh, used in machine learning. So the next one that we will be discussing is decision tree. Decision tree is something that we are doing every day. It is a type of multi-stage classifier that can be applied to a single image or a stack of images. Now, what is done in case of decision tree? Decision tree is made up of a series of binary decisions that are used to determine the correct category for each pixel. Now, these decisions can be based on available characteristics of the data set. No single decision in the tree performs the complete classification or segmentation. So you can see, suppose decision tree is very simple to understand. Suppose I want to go out to play football or tennis. Okay, so first of all, what we will look, we will go out and see how is the weather. If it is raining, that means no. If it is overcast, we will see. If it is sunny, then we will check how much is the humidity. Okay, so sunny, that means yes. Then we will check the humidity. If it is high humidity, you cannot go out to play. And if it is normal humidity, you can go out to play. So here you can see each node, each internal node checks a particular attribute. Once that comes to the next node, each branch corresponds to an attribute value node, and each leaf node assigns a classification. So classification is not done only by one yes or no. Each decision divides the data into one or two possible classes or group of classes, and go on this yes and no goes on, and we are able to decide on which class this particular pixel is to be taken. Here, suppose we are using hierarchical decision tree classifier. So these are the rule sets. So if the aspect is less than greater than 300, or um, aspect is between 300 and 359, you have to go for rule A. Okay, so aspect is true. You have to see whether the habitat conditions are there. We can my hypothesis would be proved. Okay, here you are seeing whether the uh, in value is greater than equal to 44, less than equal to 52, 31. So all these rule sets are there, and NDVI is less than within 2.2 to 0.7, and so means so many rules are there. If everything goes on yes, then only it will say that this is white fur or something. That means a particular species. Here again you can see in band 4, whether the value is less than equal to 55, then check band 2. Whether a value is less than equal to 30, then that means it is agriculture. If it is greater than 30, check band 1 value. If it is less than equal to 81, less dense built up, greater than 81, then check B2, band 2. If it is less than equal to 46, then shallow water, greater than 46, then it is dense built up. Like this, you go on making different notes and doing the taking the decision. Now, the advantage of decision tree is that it is easy to understand and interpret, and it is perfect for visual representation, because we as humans also make our decisions in this manner only. This is an example of a white box model. White box means everything is in front of us, and it closely mimics the human decision making process. It can work with numerical and categorical features. Both type of data assets can be handled. It requires little data pre-processing, so no dummy variables, nothing, means no calculations, nothing is done. Simply uh, means pre-processing is very less. It is fast for inference, and it doesn't make any assumptions about the shape of the data set. Feature selection happens automatically. Unimportant features will not influence the result. The presence of features that depend on each other also doesn't affect the quality. The disadvantage of decision tree is that it tends to overfit, means create a model which overfits, and gives very good result in case of training data, and if we give another data set, it gives us not so good results. Okay, another algorithm is means classification and regression tree. In short, it is abbreviated as CART. Now this CART is the decision tree algorithm only, which can be used for classification as well as regression problems. This algorithm is available in Google Earth Engine, and there would be one demonstration on Google Earth Engine. Okay, so CART is decision tree only, but it can be used for classification problems as well as regression problems. Now, as I have told you that the decision trees, they try to overfit the model, create a model which overfits. That means the training, it gives me very good results in case of training data, but not so good result in case of the other set of data. to deal with such type of problems, we can use another type of algorithm that is called as random forest classifier. Now, what is there in in a forest? In a forest, there are large number of trees. So the same thing, same logic we are using here also. In random forest, in the previous slides, we have talked about one single decision tree. So why should we use only one tree? We can build up multiple decision trees. So the same thing happens in random forest classification. In this type of algorithm, multiple decision trees are created. And the for when we are creating these trees, then the training data, that also we are giving different training data. So whatever is the set of training data, we are randomly choosing um, a subset of training data and providing it to individual tree. Now individual trees are asked to do the means they perform the task, they do the classification, or they do the task, and they give us the results. Now for all the trees, the results are checked, and the final result will be one the mag each tree votes, each tree gives a vote. Suppose here you can see the tree one says that it is a cat, tree two says it is dog, tree three again says it is a cat, and like this we can have n number of trees. So for whichever class maximum trees vote, that the pixel is put into that particular class. So votes are tallied to reach the final prediction. Okay, so this concept is the concept of ensemble learning. Ensemble learning is the process of combining multiple classifiers. To solve a complex problem or to improve the performance of the model. So here what we are doing, we are making large number of trees. Many trees are made. So we are using multiple classifiers. And why we are using multiple classifiers? So that we can improve the performance of the model. So the greater number of trees, why we are using large number of trees? Because so that we can solve the problem of overfitting that we have that we can encounter when we are using only one single decision tree, and higher accuracy can be achieved. Okay, so this is what is random forest classifier. Now, when we are talking about ensemble, then there are two types of uh, methods by which the classifiers can be ensembled to give better results. So one is bagging and one is boosting. Bagging is parallel in which the uh, different classifiers give predict results, and based on that the final prediction is made. The boosting is another type of ensemble method in which the results of one classifier are uh, sent to the other classifier to improve its result. Then these results are sent to the third classifier, and so on. And finally, the results are improved and the predictions are made. But anyhow, this bagging and boosting is not related here. We were talking only about random forest classifier. Now, in random forest classifier, as I have already said, that while growing the trees, while making the trees, we are adding the randomness into our model. And instead of searching for most important feature while splitting a node, it searches for the best feature among a random subset of features. Because what is happening, we are giving this is my training set. Within the training set, we are splitting that data into training data 1, 2, 3, 4, 5, and n number of training data. Okay, the entire training set is randomly splitted. Okay, there can be some overlapping also. There can be some different type of training data also. So from training data 1, decision tree 1 would be trained. From training data 2, decision tree 2 would be trained, and so on. And they will do their predictions. Finally, the majority voting would be done, and final prediction would be done. Okay, so the same thing is depicted here also. Okay, so another image which this is a very nice concept, very interesting concept. So I have put a few slides on this. Now, what are the properties of random forest? The first one is diversity. Uh, because we are taking different type of training data, so all the attributes, all the variables, all the features are not taken into account when we are creating one individual tree. Every tree is unique in its nature because it is getting trained by a different set of training data. So every tree is unique. It because each tree does not evaluate all characteristics, the feature space is decreased. So it is looking at only some type of training data, only one set of training data. So the curse of dimensionality can be, curse of dimensionality means when you have large number of data, so that large number of data is always not useful for you. It many a times it gives you a lot of problems also. So that is called as curse of dimensionality. So that also it handles. Then it does it parallelly. So each tree is built individually from various data and properties. This means that we can fully utilize the CPU to construct random forest. So the parallelization of the of computational resources can be done. Here we need not separate the data for training and testing, because decision tree is always means is not using the entire training data. Some data it is not using, some data is used by some other tree, and it is the stability comes because the final outcome is based on the majority voting or averaging. So these are the advantages of random forest. It is capable of performing both classification and regression. It is capable of handling large data set with high dimensionality. It enhances the accuracy of the model and prevents the overfitting issue. Uh, Even though we can use random forest for regression analysis also, but it is not suitable for regression analysis. So why should we go for random forest? Because it takes less training time as compared to other algorithms, because it is using a part of the training data. It predicts output with high accuracy. Even with for large data set, it runs efficiently. It can also maintain accuracy when large proportion of data is missing. The next algorithm that we will talk about is support vector machine, SVM. Support vector machine is again a supervised machine learning algorithm which is used both for classification and regression tasks. Uh, Even though we are saying that it can be used for regression, but it is uh, it is best suitable for classification. Now, in support vector algorithm, I'll go to the next slide. Now, when we are talking about hyperspectral kind of data in which large number of bands are there, in which large data sets are there, large sets of data, that means one set of data is one band, another set of data is another band. So like this, when you are talking about hyperspectral data, so in hyperspectral data, the SVM technique, the support vector machine, is tries to find a hyperplane. It chooses a hyperplane which maximizes the margin between the classes. So here you can see this blue is one class, red is one class. You can have multiple hyperplanes. Multiple hyper. Why we are using hyper? Because so many number of dimensions are there. That is why we are using the term hyperplanes. So one of the hyperplane would be such so that it has maximum distance from both the classes. So SVM tries to choose a hyperplane that maximizes the margin between classes. The points which are closest to this hyperplane are supporting this hyperplane, so they are called as support vectors. So we should read the so the main objective of SVM algorithm is to find optimal hyperplane in an n-dimensional space that can separate the data points in different classes in the feature space. The hyperplane tries that the margin between closest point of different classes should be as maximum as possible. The dimension of hyperplane depends on number of features. If the number of input feature is 2, then the hyperplane will be just a line. If the number of input features is 3, then hyperplane becomes a two-dimensional plane. Greater than that, we can only imagine. Okay. Now, what is the advantage and disadvantage? So it works really well with a clear margin of separation. It is effective in high dimensional space. So when a large number of bands are there, in such cases, it is good. It is effective in cases when number of dimension is greater than number of samples. It is a subset of training point in the decision function, so it is also memory efficient. Uh, if the data set is large, so the training time also will be very high. So that is one disadvantage. And when the data set has lot of noise, then also it the SVM will not perform very. The next one is artificial immune networks. It is inspired by the natural immune system of human body, and it is applied for solving complex computational problems in classification, pattern recognition, and optimization. It is based on principle of behavior of both B cell and T cell in biological immune system. Okay, so then we have this logistic regression. Regressions, we have talked about the classification problem. So regression is a statistical method for analyzing data set in which there are one or more independent variables that determine an outcome. The outcome is measured with a dichotomous variable. The goal of logistic regression is to find best fitting model to describe relationship between the dichotomous characteristic of interest and set of independent variables. So it is logistic regression is a method of binary classification. So only one set of classification it can do. It can discrete between 0 and 1. So it does not require too many computational resources. So in cases where we have to use only, or we have to classify our data only in two classes, yes or no, then we can go for this logistic regression type of thing. The second type of classification algorithms are unsupervised learning. As the name itself suggests, we are not giving the training to our system, to our models. Instead, we are asking the computer to find out the natural pattern in the data set. So I would like to explain this with the help of this figure you can see here. So if you look at it carefully, you will see that this pixel which is having value 12, 14 and 11, they are similar in terms. I will not say it is same, it is similar. Similarly, 178, 177, 181, 180, 183 value pixels are also similar. So we can assign them into cluster A, cluster B, cluster C, so on. So this is what is called as unsupervised clustering. So supervised learning method in which unlabeled data points are grouped into clusters that share similar properties. The two unsupervised learning tasks mainly are clustering and reducing dimensionality. So these are the unsupervised learning algorithms, clustering algorithms, k-means clustering, spectral clustering. Then we have dimensionality reduction, such as PCA, principal component analysis, factor analysis, and okay. So the unsupervised, what is the advantage of unsupervised learning? So clustering automatically splits the data set into group based on their similarities. You can use it for anomaly detection also. Anomaly detection can discover unusual data point. It is useful for finding fraudulent transactions. Association mining identities, sets of items which often occur together in the data set. What are the disadvantages? We cannot get precise information regarding data sorting, and the output as data used in unsupervised learning is labeled and not known. Uh, the results have less accuracy because the input data is not known and labeled by people. The spectral classes are generally always not correspond to informational classes, such as the agriculture field. Agriculture field, with standing crop, with crop, with where the crop has just been sowed. So all of them will have different spectral values. The user needs time to spend interpreting and labeling the class which follow that classification. So an algorithm of unsupervised classification, that is k-means clustering, so assigns data points to one of the k clusters depending on their distance from the center of the cluster. So from the center of the cluster, how uh, spectrally how much, at how much distance the particular pixel is. Starts by randomly assigning the cluster centroid in the space. Then each data point assigned to one of the cluster based on its distance from the centroid of the cluster. This process runs iteratively until it finds good cluster. Okay, so now these are the differences between supervised and unsupervised learning. In the What is the objective of supervised learning? It is to approximate a function that maps inputs to outputs based on the training data. Unsupervised is to build a concise representation of the data and generate imaginative content from it. The supervised may be highly accurate and reliable. Uh, Unsupervised would be less accurate, but it is reliable because it takes natural clusters into account. The supervised is a simpler method, whereas unsupervised is computationally complex. In the supervised learning, the number of classes is known. You can classify into 10, 15, 20 classes, whereas in unsupervised class learning, you can have unknown number of clusters. In supervised learning, the output is a desired output value, whereas unsupervised learning, there is no corresponding output value. Then there are some methods of semi-supervised learning. By using semi-supervised means the we have the labeled points, or we have the training data, but we have very few labeled data. Okay, so based on this few labeled data, you can do the initial classifier optimization, then classify the unlabeled data with trained classifier to label them, and finally retrain the classifier. Okay, so by using semi-supervised learning, it is possible to combine the advantages of working with small labeled data set to guide the learning process, and larger unlabeled data set to increase the generalizability of the solution. Then this is reinforcement learning, in which the software is trained to make decisions to achieve the most optimal result. It mimics the trial and error learning process that humans use to achieve their goals. Software actions that work towards the goals are reinforced, while actions that detract from the goal are ignored. It follows the concept of hit and trial method. The agent is rewarded and penalized with a point for a correct or a wrong answer. And on the basis of positive reward points gained, the model trains itself. Once trained, it gets ready to predict the new data presented to it. The reinforcement learning algorithms use a reward and punishment paradigm as they process the data. They learn from the feedback of each action and self-discover the best processing paths to achieve final outcomes. The benefits of reinforcement learning in complex environments, it gives us a very good accuracy. So it can be used in complex environment with many rules and dependencies. It requires less human interaction. In case of traditional machine learning algorithms, humans must label data pairs to direct the algorithm. Reinforcement learning algorithm learns by itself. It also optimizes for long-term goals. So this is all for the session on machine learning. Thank you for joining in this session. We'll take a small break and then we will reassemble for the question and answer session.